So for problem number 5 in section 5.3, there are two problems. I want to go over the second one, but let's discuss the first part. This is a single exponential structure you have here, and what we are looking for is the exponent. Therefore, we say the general drill is to convert it into the corresponding logarithmic structure where they share the same base. The output of exponential function is the input of the logarithmic function, and then you end up with x minus 5 here. And once you figure that out, what you can do is to find your x pretty easily. It tells you that x is log 4(3) plus 5. But of course, it's not super obvious to us how to input the function value of log of base 4(3). So you either punch into your calculator or you use the formulation we discussed in class. If you had log b of a, it's mathematically equivalent to log m of a divided by log m of b, where m is a shared base used in the numerator and denominator, which should be greater than 0 and should not be 1. So the popular choices of m would be 10 or e. Therefore, I can rewrite my problem where the log 4(3) is the same as log 3 over log 5, or if you want, log with base 10 of 3, and that. So if you don't want to do simplification, you could have punched in ln3 divided by ln4 plus 5, which would be treated as a correct answer. So the next problem is slightly more challenging because you have two pieces of log structure add together. Well, sorry, lucky for us, two log structures sharing the same base can be easily merged into one with its property. The property says this: if you log m of x plus log m of y, it's the same as log m of x times y. Therefore, your problem is the same as log of x times x minus 1 together equals m. So you have one single log structure equals 1. You are looking for the input of it. So along the same line of thinking as the previous problem, when you have a single exponential log structure looking for the input, you are going to convert it back to the corresponding piece. In this case, you're corresponding to the exponential function, which is something that looks like that. Therefore, what you end up with is x squared, which by the way is x squared minus x if it's not super obvious to you. So it's x squared minus x minus e equals 0. So your x is negative b plus or minus square root of b squared minus 4ac over 2a, which is 1. And therefore, you have positive 1 plus minus 1 plus 4e over 2. So this technically means two different numbers. The first one is 1 plus square root of 1 plus 4e over 2. The second one is 1 minus square root of 1 plus 4e over 2. So technically, I may want to choose both of them, but like remember what I said, whenever you have a log structure in your expression, you want to make sure whatever input you put into it would actually make sense. So according to this problem, you should have realized that the first one tells you x is greater than 0. The second one tells you x is greater than 1. So in short, what you want is a number that's greater than 1. If you look at those two expressions, the first expression is 1 plus something greater than 1 over 2. So this is greater than 1. That's good. This one is 1 minus something greater than 1. This is actually less than 0. It doesn't work. So your only answer for this problem, as a matter of fact, is simply this. It's 1 plus square root of 1 plus 4e divided by 2.